This will be for the con exercise direction of vectors. So for this exercise, we're going to be using some trigonometry. If you remember SO, CA, TOA, the only trig function we're using for this is the tangent. Okay, and the tangent formula equals opposite divided by adjacent. Okay, so that's tan of an angle theta, opposite divided by adjacent. If you remember from your triangle, the Greek letter theta represents the angle. And if you go across from that angle to the side, that is going to be your opposite. If you go across from the right angle, that's going to be your hypotenuse. And the remaining side is going to be your adjacent. Okay, so we don't need to worry about hypotenuse for this exercise. Okay, the other thing you want to remember is that when you measure an angle on the XY coordinate plane, you start with the positive x-axis and you measure from that axis. So if we were to measure the angle of this vector here in pink, we would have to start here and go around this way. Okay, and the angle would be this whole thing right here. This would be over 90. This would be about 135 degrees. Okay, so you start with the positive x-axis. Okay, so we have a vector u, -2, 5. They want us to find the direction angle of vector u, and it has to be between 0 and 360 degrees. All right, so if we sketch this, we are going to travel -2 on the x-axis, so that is about right there. And then we're going to travel 5 units on the y-axis. Okay. Alright, so I redrew this to make it a little bigger. Okay, we have -2 on the x, 5 on the y. And remember, the vector starts at the origin. So this, I drew it crooked, hold on. This right here is going to be our vector. Okay, so remember, well, let me make the angle first. We can see this here, since it's x and y, this makes the right angle. Okay, and this right here, the angle is going to be with the origin. So this right here is going to be our Greek letter theta. That's going to be the angle. All right, so if you go across from the angle theta, that is going to be your opposite. If you go across from the right angle, that's the hypotenuse, but we don't need that. And the remaining side is going to be your adjacent. Okay, but remember we said we don't want negative side lengths for the triangle. So I'm just going to make this a +2 for now. Okay, and we're going to find this angle theta. We have the tan of an angle theta, and that equals opposite over adjacent. Okay, from the formula. So we're looking to solve for theta. And we have the tan of the angle theta is going to equal opposite, which is 5, divided by adjacent, which is 2. Okay, now the way to remove the tan function and be left with the angle theta, you want the inverse tan of both sides of this equation. So you also want the inverse tan of 5/2. Okay, on the left hand side, the inverse tan and tan cancel, and that will give us the angle theta if we just do this on the calculator. Okay, make sure you're set to degrees. Okay, on the calculator, inverse tan of 5/2, rounding off, I get 68.20. Now, that is not our final answer. Okay, that's just the angle theta right here. So I'm going to replace this with 68.2. Okay, this angle here is 68.2, but we want to find the angle for this vector. Okay, so remember we said you have to start with the positive x-axis and go this way in order to measure the angle. All right, so if we started here and went all the way around to here, that would be 180 degrees. Okay, because a straight line is 180 degrees. So we just have to subtract this piece from 180 in order to get this angle right here. All right, so this angle in here is just going to be 180 minus 68.2. And I get 111.8. Final answer. Okay, so this angle is 111.8. All right, they said round to the nearest hundredth. That's 2 decimals. So when I found the initial value of theta, I did 2 decimals and then subtracted from 180. That's 111.8. So really, you want to find the angle of the vector starting from the x-axis. Okay, here we have the vector -7, -10. So let's draw this out. Okay, so we said -7, -10. So I'm going to go -7 on the x. And then I'm going to go -10 on the y. And then I'm going to draw my vector. Starts at the origin. Okay. So we will start by finding this angle right here. All right. Remember that we want positive side lengths, so I'm just going to make both side lengths positive. Okay, if you go across, that is your opposite. Across from the right angle is your hypotenuse. We don't need that. And the remaining side is your adjacent. So remember that the tan of an angle theta is opposite over adjacent. So we have tan of theta. Opposite is going to be +10. Adjacent is going to be +7. In order to get rid of tan, we need the inverse tan. So you do the inverse tan of both sides of this equation. So I am going to do this on the calculator. Okay, make sure it's set to degrees, and you can round it to 2 decimals. Okay, so rounding off, I get 55.01. And of course, inverse tan and tan cancel. That is our angle theta. Okay, but that's not the final answer. Remember, we are measuring starting from the positive x-axis. So the angle that we're measuring goes all the way to this vector. It starts here. Okay, let me erase some stuff. The angle actually starts here and goes all the way around to this vector. Okay, so this part here, from here to here, is actually going to be 180 degrees. because that is a straight line. So from here to here is 180. That's half a circle. And then we just add this piece right here, which is theta. So we're going to add 55.01. And that will give us 135.01. So that is the final answer. I'm sorry, I meant to say 235.01. So just click inside the box and type 235.01. You're rounding to the nearest hundredth. So that's 2 decimals. Alright, if you want a little shortcut, just so you know, whenever you draw this, the y component is always going to be your opposite, and the x component is always going to be your adjacent. Okay, but you still want to sketch this just to find out which quadrant you're in.